In our previous lesson, we talked about software applications, and in this lesson, we're going to concentrate on one of those software applications, that database application. First of all, as far as some definitions on information systems and their components, an information system, which you hear a lot of in or will in many of your classes, but especially this class, consists of the data, the people, the processes, along with a combination of all the hardware that's used, the software, and the communication technology. All of that is known as an information system. Information technology, or IT, which is another term you may have heard, deals with the technology that connects these systems together. I've also mentioned this before, but I want to go over this again as far as the difference between data and information. Data are raw facts, or that's the input. It has no meaning on its own, basically, but once it is processed, then it becomes information. And so the information system, that's what its job is to do, is to refine that raw data into meaningful information. In regard to specific information system activities, input, processing, output, storage, and then one more step as far as controlling. And you'll see this in a lot of things that we talk about, not only in this class but in other classes, is there's always a next step as far as controlling to make sure that what we're doing is correct. Don't just assume because we have an information system in place that the output that we are receiving is what we need, or that it is correct. There has to be constant follow-up or controlling to make sure that what we're getting out is what we need and it is correct. The most critical resource in healthcare is the patient data. And of course, anybody going into health information management in any form whatsoever, that's what their job is all about, is patient data. Now, the most important functions of any healthcare information system involves creating the information, being able to modify it, delete it if needed, and to actually view patient data. We always have to, especially with the electronic health record, we have to not only have the data, we have to be able to view it and have access to it when it's needed. Just like with a paper record, we have to know where those paper records are just in case they're needed. We have to know 24/7. So if we know that a patient's record is on a computer, but we can't get the computer to give us the information in the system, then it's no good to us. The most important storage mechanism used to perform all these functions above, to create, modify, delete, view patient information or data, is a database. Now, database management systems, those systems, information systems that are there to manage data, are the software programs for storing, organizing, and manipulating those large amounts of information that we have to keep in health or health care. So as far as a simple definition, a database is a collection, and that should say is a collection of information that's accessible by computer. And I mentioned this in the previous lesson. It can be something very simple, just like an electronic address book, or as big as the U.S. Census, which basically is a listing of everybody that lives in the country. Let's look at the elements of a database. One or more sets of information collected in a table. That's what a database is. And a table consist of rows called records. So across the row, that's regarded as a record, and columns are called fields. Now, there's an easy way, sometimes it's confusing to remember this, but think of a patient's record, and if you open it up, you have the same information. When I say the same information, I mean the same basic information on every patient. If it's an inpatient record, you're going to have that face sheet and the H&P and the discharge summary, and so it's the information on one patient is in a record. And so that's the same thing in the row on a database, and I'm going to show you an example in just a minute so you can actually see this. But a record has information on one person. And so if you'll notice on the row of a database, it's one item. That item could be a patient, and it's all the information on that one item or individual. The columns are called fields, and that's, for example, in column 1 of a database, it could be patient's last name. So it's the same data item on everybody, but it's different because it's different individuals. And just to clarify that in just a second, I'll show you a picture. Now, when you have multiple tables in a database and they have at least one field, so that field, that bit of information, last name, first name, medical record number, they have one in common, they are called relational, and you can link them together. They can be linked or joined. So a relational field is one that appears in common in multiple tables in a database. A field that is a unique identifier can be named as what is called a primary key and can be useful or can be used as that relational field. And I know as I'm saying this that you're scratching your head going, yeah, right. Just a minute, and I will actually show you a picture of this so you can, it will make more sense. Now, something that's a unique identifier, if you have two tables in a database, and each of these tables has information, let's just say we're keeping patient information in this database. And one table has a field where the patient's medical record number is contained. And then you have another table that's keeping patient data, and it also has a field that says patient medical record number in it. A medical record number is a unique identifier, and what I mean by that is that no two patients should have the same medical record number. It's going to be different on every patient. And we can't say that about many other things that would be kept. For example, last name. What if we kept last name on the patient? Is that a unique identifier? If you think about it, no. What if somebody's last name is Jones? Well, there may be 1,000 other patients that have been seen at the hospital with the last name of Jones. First name. Date of birth. Many people can have the same date of birth. Many people can have the same address. Some people can have the same phone number. And so the one thing that is always a unique identifier is the medical record number. So many times it's designated as what's called the primary key, and it can be used to link two databases together. Now the corresponding key in the other table, or in another table that has that same unique field in it, is called the foreign key. And so it's designated as the primary key in one table, and if it's in another table, it's just called the foreign key. They're basically the same thing, but those are the two fields that are going to match up, or that be able to link two tables together. Here's an example with Microsoft Access. This is actually setting up a database in Microsoft Access and identifying the fields or the columns: last name, first name, middle name, date of birth, street address, city, state, zip code, those types of things. And notice under medical record number that there's a little key right here. Now, Access allows you to designate a field as a primary key. And notice the one that was chosen is the medical record number. Now, I set this up, I was setting up a master patient index in Access. And so I chose that, the medical record number, as the primary key because what did we say? In order to be used as a primary key, it has to show up in 2 separate databases or more, but let's say 2. And it has to be a unique identifier. If you look at all these other fields, last name, first name, middle name, date of birth, all of these things except medical record number are not unique identifiers. Other individuals or other patients could have the same characteristics, the same last, first, and middle name and date of birth. I've seen that happen many a time in hospitals when you're trying to identify a specific patient, and lo and behold, there's 2 people with identical names and dates of birth. And it's not common, but it does happen. 2 people can live at the same address, in the same city, of course, same zip code, and so the only unique identifier would be the medical record number, so we designated that as the primary key. Now note, as I said, this is just when I was setting up the database in Access, or that master patient index. Here it is in table format after data has been entered. We have last name, first name, middle name, date of birth, medical record number, that's that primary key, that's the only unique identifier, and so this is actually in table format. Now, this third screen is actually what it looks like after it's been formatted to say, okay, when I look in this master patient index, I want to see it in this format rather than in that table format. It's the same information, last name, first name, middle name, address, date of birth, here's that medical record number, and so all of that information was shown on that table, but we're just showing it in a different format here. So I want to go back one screen. Remember, we're talking about records and fields. This is a record. It's a row. So it's various information on one patient. So that's that patient's record. And then a field is one type of data on everybody. And so a field is a column, a record is a row. And as I said, the way that I always remembered it is that a record gives various information on one, in this case, patient. A database doesn't have to just be on patients. It can be, all types of companies and individuals keep databases, but we're just working with patient data. Let's look at various types of databases. There's a database called Flat File, and it just has one table in it, and it can't be linked. So a very simple database, a flat file. We already mentioned a relational database. It has multiple tables, and it stores data in predefined tables that contain those rows and columns. It looks kind of like a spreadsheet. It looks a lot like an Excel spreadsheet. The kinds of data that can be stored in a relational database are currency, numbers, integers, strings of data. We saw that text, as far as patient's name, those types of things can be stored in a relational database. We talked about that primary key. If we want to link those tables in a database, we have to have one column that's in both tables, and it needs to be a unique identifier. That could be an account number. That would be maybe a unique identifier. Medical record number, definitely is a unique identifier, and then that foreign key is a field that corresponds to the primary key in another table, which allows two of them to be linked together. We have something called an object-oriented database. And in this type of database, instead of just storing text such as name or numbers, it's more advanced, and it can save graphics, can put movies in a database, audio files, those types of things. Alright, if I hadn't confused you yet, let me try harder. Now we have an object relational database, but just look at it. If we know that an object database or object-oriented allows us to store more advanced things such as pictures and movies and sound, we said you can link the tables in a relational database. So object relational database uses both traditional data types and advanced data types and can be linked. Now, hierarchical database, I'm giving you this, not that I care that you understand it, but I do want you to know the terminology. If you ever hear the term hierarchical database, databases allow us to search the data that's in there to retrieve particular data that we may want. Now, in a hierarchical database, the only thing that I care that you remember about this is when that search is performed, it is from parent to child. And what that means is it's the way the database is set up. A hierarchy means from the bottom to the top or from the top down. And so data is stored and it's kind of connected to each other. Different data are connected, and so when the search is done, it'll go one place and look, and then if it meets a certain criteria, then it'll go deeper into that place and look. And so they call it a search from parent to child. But I do not want you spending any time trying to figure out exactly how this actually happens unless you're going to pursue a more advanced degree in computer science or something like that. But hierarchical database, I do want you to recognize the term and know that if you hear the term in a hierarchical database, when a search is done, it is searched from parent to child. Now, the common features of a database, we talked about this previously when we just briefly mentioned databases when we're talking about the various application programs or software programs. In a database, you can sort, you can find, you can ask questions. We talked about that structured query language is how it has to be written in order for us to ask questions of the database. We can link the tables of a database. We can get output, such as certain reports that we need. We can do mailing lists, mailing labels. So we can manipulate that data that's stored and have output that fits our needs. Now we have new uses of databases. These are very common terms that you hear a lot now about data warehousing and data mining. Data warehousing, we keep so much data. In data warehousing, are data files or pertain to data files that are stored for future examination. And so they're stored even though they're stored after they've been used, but they may be used later for a totally different reason than why they were originally collected. And so just that process of storing them is called data warehousing. And then when we actually go in and examine what's warehoused, we may discover new uses for that, let's say, old data. So we may discover potentially new information. And so that's what data warehousing is, actually the keeping of data. But then mining it means going in and examining it to see if it can be used for a new or potentially new and useful purpose. Now, a data repository, and we're going to repeat this when we talk specifically about the electronic health record. There's a database that's developed in an open format that allows the facility to access data stored in various systems. Now, to say that in plain English, there are a lot of different health information systems, meaning the lab may have a particular health information system, so a lab information system. You have radiology may have a different system. The pharmacy has a different system. They're all health information systems, but they have different data being entered. They have different functions and different purposes. But a clinical data repository is actually a database that can gather and store data from these different systems throughout the healthcare institution. And notice it's called a clinical data repository. And so different systems throughout the facility, but to bring together the data that are collected in these different systems, it put into a specialized kind of database called a clinical data repository. Now, another definition, no pun intended, data dictionary. Dictionaries give definitions, but this is very important as far as database management. If a facility has a database, then they're going to have what's called data dictionary. And what a data dictionary is just a centralized repository, and then that term's coming up again, a place to put things, basically. That's a repository of information about the data stored in a database. It provides the definitions of each data element, the characteristics of that data, the relationships to other data, the origin, usage, format, and I know that's a pretty big definition, but look at this other one. Same category, just worded differently. A super catalog that provides for each data field or element a list that describes the information or the data, where it came from, what the values could be, what type of field is it, how big is the field, the security level, meaning who can access that data, the codes, if any. And when I say codes, some data that, you'll be entering data on for example, assigning codes to diagnoses and procedures, and then that will be put in to a database. And so that's coded data, or what they call codified data. Also, any applications or reports that use that data element. So think of it this way. When we're talking about a data element, that's just, think about the table. And for example, if we had last name, that's a data element. And when we put it in for a patient, John Smith, and we're looking at that data element that is last name, okay, the definition in that data dictionary would be that that field can be up to 25 letters. It's an alpha field, meaning all letters, no numbers. Where it comes from, for example, that's probably originates in admissions during the registration process. So that's all it means by defining all of this, is you take a specific data element, which is just one of those fields, whether it's last name, date of birth. For example, if it's date of birth, what format's it in? How long is it? Is it 02/11/1972 or / just 72? How is that recorded? Is it all numbers? Can there be any text in it? So that's all it is. It's just defining every little element of data that will be put into a database and giving its characteristics and its definitions. Another example, what if you had a data element or a field that was for the patient's sex? It could be codified to say that if it's for example, a numeric field, and you're thinking, well, why would sex be a numeric field? Because you can put in 1 for male and 2 for female. And so that data field would be defined as being a numeric field that's only 1 character in width, or that's how many digits would be put in there. And so hopefully that makes it a little bit more simple as far as to what that data dictionary actually is. Now let's look at data quality. Now that's a biggie. If we're going to keep data, and especially in health, that data has to be quality data. And so patient data can either be individual or what is termed aggregate data. Individual data, just as it sounds, that individual data kept on every patient, and it is identified through that patient. You know, for every patient's going to have different data. Aggregate data are data that are extracted from those individual records, and then they're combined. They'll be de-identified, meaning you don't care who the person is as much as you're looking at the overall picture and the numbers. And so that information can then be grouped together for comparison and for analysis, and that's all that aggregate data are. Data that are taken from individual sources and then combined to be analyzed. I want to look at the characteristics of data quality. Okay, if we say we want quality data, how do we know we have quality data? Let's look at, for example, data accuracy. Now that term's pretty straightforward. We want the data to be correct. We want data accessibility. We said, okay, we have all this data, but if we can't get to it, it does us no good. So data accessibility is another characteristic of data quality. Is it available? Data comprehensiveness. Are all the required data elements included in the health record? Meaning, if we have an electronic health record, are we gathering all the data that we need to be gathering on every patient? Data consistency means that once that data is entered into the health record, it doesn't change. Meaning, intentionally change or through some type of technical glitch. There can be all kind of ways that electronic data could possibly change. So we want to make sure that the data are consistent, that they're current, that data are entered at the time of the event and not a long time later. That's one of the advantages of the electronic health record, that data are available much quicker to caregivers. We have to make sure as far as that there's data definition. So we have that data dictionary so that all users will know the meaning of the data. To clarify that a little is, remember when I said a minute ago, okay, we have male and female, and we may decide to have that codified and be putting in a 1 for male and a 2 for female. Well, everybody needs to know that. So the data mean the same thing to all of the users of the system. Now, data granularity, that term granularity may not be one that you're familiar with, but in regards to data or in any situation, granularity means the degree of specificity. How specific is it? So it means that attributes and values of the data are defined at the correct level of detail. Now again, to put this, or try to put this in plain English, let's give an example. You have lab reports, and lab reports have data. Maybe it's a urinalysis or blood work. But let's just say, just in general, you have a lab value appearing on a certain type of lab test, and it's normal from 1.2 through 1.6. Less than that, it's abnormal. Over that, it's abnormal. Well, what if when you define the data that you said it can only be one character, so it's being rounded up or down, and so that lab value that appears as a 1.1 would be recorded as just 1 in the record, and something that was maybe 1.6, which is in that normal value, would be rounded up and recorded as a 2. And so it's not specific enough to actually even tell if that lab value is normal or abnormal. So all the granularity is, are you carrying it out far enough? Are you being specific enough with the data that are entered? Are they at the correct level of detail? Data precision, that refers to acceptable data values. A good example here, if you were coding and y'all started on that journey already, you're not way far into it, but you do know that if you're coding ICD-9, there are certain characteristics that it has to be 3 digits, or 3 digits and then a decimal place, and some codes, the majority of them have 2 more digits, so they have 4th and 5th digits. But if you put in a value that was 10 digits with no decimal points, that's not an acceptable value for an ICD-9 code. And so that's not precise, it's not a correct value. So hopefully that makes sense, that the data that are being entered are acceptable values for that data. Data relevancy just means, are the data useful? As I said, we gather so much data. Should we gather it if it's not relevant, if we don't use it? Why are we gathering it? And sometimes we gather data because we have to, because of Medicare standards or Joint Commission standards. We gather data that's relevant for the treatment and diagnosis of the patient. But some data may be gathered and they're just not relevant. It costs money and it costs time to actually gather and store this data. And so we need to make sure that all of it that's being kept is actually useful. And then finally, data redundancy. We need to make sure that data are required to be entered the least amount as possible. Meaning you're doing something in health information, you're having to constantly enter patient name and medical record number. That's already been entered via the admission systems or the registration systems. And so to make sure that we're not constantly entering the same data over and over and over again, and if we do, that's known as data redundancy. So those are the characteristics, or how we can measure if the data that we gather and that we keep are actually of quality. Now, 2 types of checks that can be programmed into an information system that can aid in the detection of errors are called validity checking and reasonableness checking. Now, validity, you've heard the term valid, so we're checking to make sure that the data are valid, and actually the system is checking it. And so this is the determination that the value of a data item is a member of a set of valid values for that item. And so if the system does validity checking, it's checking to make sure that something is valid that's put into the system. And many times, if there is this type of detection with our system, we'll get an alarm or alert, or it won't let us put in values that aren't supposed to be there. And so, for an explanation, or to define this even more, the fact that a data item is valid doesn't mean it's correct or that it's right. So an example of this is, as I was mentioning a minute ago, you have an ICD-9 code. You're entering a code into an information system. ICD-9 codes, just by rules, have to be between 1 or 001.0 and 999.9. They have to be. If they're not within that range, they're not valid. They're not valid codes. So if somebody tried to enter a code of 7772.94, it's not a valid ICD-9 code. And the system would say, this is not a valid code, and wouldn't allow it to be entered. Also, another example of this as far as validity checking, if you put the admission date, if the admission date's in the computer, and on discharge you're entering the patient's discharge date, and you put the discharge date as a date before the admission date, that's not valid. Somebody can't leave before they even get there. And so that's all that validity checking is. Now, reasonableness checking goes a step further and determines that the value of a data item is reasonable in the context in which it occurs. And so to explain that, let's look at an example. A patient's daily weights are recorded in the record. As the doctor wrote an order and said record the weight every day or every 24 hours. The patient's weights are recorded. One day is 120, one day 121, one day, the next day 120, and then the next day 157, and then the next day 119. Now all of these are valid. Somebody can weigh 120, somebody can weigh 157. Those are valid weights, but they're not reasonable under the circumstances. So even though that 157 is a valid weight, it doesn't mean that it's reasonable. Normally somebody doesn't gain 37 pounds within 24 hours and turn around and lose 38 pounds. It's just not normal. I mean, it could happen in some disorders, maybe a huge accumulation of fluid in the body or something, but under normal circumstances, this just isn't reasonable. Again, it's valid. And remember, under validity checking, we said just because something's valid doesn't mean it's correct. So those are valid numbers, they're not reasonable. Another example, a male patient's given an ICD-9 code of 68.9. That's a valid code. It's within that range for ICD-9 codes for the procedure codes, and that's a valid code. But it's a code for a hysterectomy. And so even though it's a valid code, it's not reasonable considering that before, under sex, it was keyed in that the patient was a 1 or a male. And so the system would do an alarm or alert. Sometimes it won't let you put things in that are not reasonable or valid, but other times it just reminds you and say, look at this and make sure. A lot of the times this would happen. I remember putting in or abstracting data, and if you tried to put in, if somebody had Medicare and then they also had another primary insurance because they were still working, the system automatically assigned the Medicare as the primary insurance. And so if you tried to put something else in, you would get an alert and say, are you sure? Because Medicare is usually the primary. It's not a secondary insurance, but there are cases, and it would let you go on and override that. And so look at that, determine the difference between validity and reasonableness checking. Now, in summary, we looked in depth at the functions of a database, those different elements of the database. We looked at specific types of databases, and we defined the different characteristics of data quality.